Ladies and gentlemen, it's been quite some time since I made a video on this channel, but I'm excited to be finally making a new video today. I've gotten some time. It's been quite busy the past few months, but today I want to look into a new tool that I think adds something that is currently missing in the arsenal of smart contract security tools. And that is something we've looked into before, and we found that the existing tools for this area of smart contract testing is they're not really fully automated, or they're not really in depth enough, or just more work needs to be done. But today we'll be having a look at a mutation testing tool that is fully out of the box. You can just run a command, and it'll actually mutation test all of your tests and for any arbitrary contract, and we'll see why this could be so powerful. Of course, the tool we're having a look at today is Olympix. Now, I've got the Olympix webpage pulled up here, and I'll just zoom in a little bit, and as you can see, it's sort of positioned as an AI tool, something that will help even just developers start to bring in security really effortlessly in the product development pipeline, which I'm actually pretty bullish on. And I think we'll talk a little bit more about this, but I think mutation testing is a huge part of getting something to audit that is already having a certain degree of security, and I mean really just overall correctness when you come in with a finalized commit for a review. But essentially, this is just one of the tools from Olympix, is this mutation testing sort of engine that they've got. And we'll actually have a look at, they've got a static analyzer as well. They've also got some like auto test generation, which we won't have a look at today, but we will have a look at the static analyzer, see how it compares, and just get familiar with that. And then we'll talk about the thing that I'm personally most excited about, which is the mutation testing. So yeah, a lot of cool stuff, a lot of cool tools that are being developed from Olympix. So we're going to have a look at a couple of them today, and we'll see exactly how powerful they turn out to be. All right, and of course, right before we dive in here, my name is Owen. I think like 3 years ago, yeah, about 3 years ago now at this point, I co-founded Guardian. And now currently 3 years later, we have worked with some of the largest DeFi protocols in the space. We've secured over $3 billion of assets on chain. We found hundreds and hundreds of critical and high vulnerability issues in smart contracts, and we continue to uncover more vulnerabilities and continue to work with some of the most targeted DeFi applications in the world to secure their code against bugs in general. And of course, my goal with all the videos that I make, and especially with this one, is to share basically everything that I'm seeing in the space, everything that I've experienced, and hopefully give it to you so that you can become, first of all, maybe interested in smart contract security research, but also if you're already interested, become better and maybe hopefully use some of the things that we explore and use some of these things that I've seen in my expertise and experience as a security researcher. So, okay, with that out of the way, let's get into Olympix. Okay, so to give a good sort of like sandbox test for what we're going to be trying out here today with Olympix, I've got a pretty simple Foundry repo pulled up here, but it's not so simple that it's just boring. This is actually an example of a more simple code base that you might actually see live in production, or you might actually see in a security review. I've got a very simple implementation of a perps protocol here. So this is one that I've made myself. I made it over, I think, a year ago. Well, yeah, about a year ago at this point. So I don't even really remember how the implementation exactly works. I do know one thing. I know there are for sure bugs in this implementation, but I've forgotten what they are. So we'll see. We'll see if we can leverage some of these tools to actually find them. But this is the implementation. You can see it's really, really not a long one. It's only about 330 lines, not even compressed. It's not normalized code. So maybe like 250 slok in this main perps contract. And then we've got in Oracle, which is really nothing fancy. It's just some decimal handling and getting the price. We've got just a library for really just a very simple calculation. That's really it. It's very, very minimal, hence the name minimum perps. So yeah, it's really as simple as a perps protocol can be. Some of the features that we're dealing with here, we've got some borrowing fees going on. So the traders will pay borrowing fees for the size of their perpetual position. Of course, traders can trade on an index token with leverage. You can go ahead and use this increase position function to make a position or increase the size of your position. You can use this decrease position function to decrease the size of your position or close your position. Of course, you can be long or short. You can be a certain amount of leverage up to limit. And then there's liquidations if you end up losing too much and your leverage goes way too high. And then, yes, I think really that is all that we've got. Obviously, we've also got the LP side. So this is an ERC 4626 volt. So sort of hiding a little bit of the complexity here that's actually underlying. But what you can do is, as a counterparty to the traders, you can go ahead and deposit whatever the collateral asset is assigned as, and essentially you just take the other side of traders and you should be getting paid out borrowing fees if that's all functioning correctly. So that's the high level of this contract. Let's see. So first we're going to have a look at the Olympix static analysis tool, and then we'll have a look at the mutation testing. We'll have a look at my tests. We'll see how good I've done at testing this system and see where some of the gaps might exist. So you'll notice I'm in VS Code, and we've actually got this button, which you might not have unless you have the Olympix extension installed. So you can see this is the Olympix tool right in VS Code here, which is actually pretty nice. So once you get this, once you get an account at Olympix, you can basically just go ahead and get this extension in VS Code, and then just use it natively right in your code editor if you use VS Code. And this is their static analysis tool. So if you aren't familiar with static analysis tools, essentially this is just going to parse through the code and try and find some initial flags that will potentially lead to vulnerabilities or just straight up be vulnerabilities themselves. So probably the most popular one that everybody is familiar with is Slither from Trail of Bits. Not a huge fan of, or I guess I've just really stopped using static analysis tools. I personally don't really use them when I do a review. I'm sure I know other team members at Cardian do, of course, use these and find them useful in their own approach, but personally I don't really rely on them, and I actually can't remember the last time that I've used a static analysis tool. So hopefully this Olympix tool turns out to be something impressive, but we'll see. I don't know. I'm not hoping for too much. I'm really more interested in the mutation testing, but we'll go ahead and try it out here. Let's just run start analysis. So it looks like we can do that, and it's pretty quick, and it didn't crash, which is probably the #1 upside. Is like if it was actually able to be run. That's probably the biggest pain, is like with a lot of the code bases that you end up actually reviewing in practice, there's a lot of stuff going on. There's many contracts. There's, oftentimes there might be some kind of weird setup, and whatever static analysis tool just doesn't work. So that's a pain point, as well as just, like Slither crashing or something like this and just not giving useful output. So it ran. So that there's bonus points already off the bat. Let's see what we've got here. So it seems like we've got 4 potential issues here. A couple of potential reentrancies, and then an unused return value. So let's see, it seems like, okay, if I click on that, we're basically shown an explanation, it seems like, of, okay, here's what reentrancy is. Yes. Let's see. Okay, yeah, so just explaining, what is the detector here. So let's see, I think I'll have to click on the actual line here. Okay, so let's see. They're saying there's a potential reentrancy. It would be nice if there's like, is there some kind of like external call that it's related to? Or is it just because this is an external function without, let's see. I want to know what is the related external call that could reenter. I don't know that I'm going to get that. Maybe they're saying it's the safe transfer from, but of course this will be a trusted asset. Let's see, what are the other instances? What do they have in common here? This liquidate function, decrease position. So, but these are not just functions that are external. These are, okay, so it seems like, let's see, what's in common here? Got an increase. Are these just all the ones that call safe transfer from? It seems like it because this one comes in here and it calls, there's definitely going to be a transfer here. Yeah, a safe transfer to the trader. Yeah, I mean, they're technically right. Like, if this was a callback token and it inadvertently made callbacks, yeah, there's a potential because if I mean, here it's at the very end of execution, so I don't see any other, let's see if I can drag this over. Any other, there's one here though. If it's a liquidation, then there's a liquidation, but that's to this message sender, and then I guess the message sender might be able to do something wacky. So yeah, I mean, if they're callback tokens, then definitely, probably it's just worth throwing an honor engine, or at least maybe just moving this down. Although I think, yeah, moving probably the transfer down, keeping this logic here, because I think it's important to have priority with when we're taking the liquidation fee. So I would say that's a worthwhile recommendation, is like, if it's even possible, if it's even remotely possible that the asset would be the a 777 callback token, then sure, let's move this down to the very end. Yeah, so I think that's a decent recommendation. Let's see, so that's the one for liquidate and decrease. Let's see, what are they calling out here? Is it just going to be this first one? In which case, I'm going to take issue with that. Let's see. So what kind of calls do we have? It's kind of fun because it's almost like we're auditing something that I wrote a year ago and I don't remember anything. So it's like fresh code. So, okay, so validate non-empty possession. That doesn't have any external calls. Nope. I wish I could do the thing where you do command back bracket and you just go back in IntelliJ. One of my favorites. Okay, validate max utilization. This, I also think, maybe there's like an Oracle call. Yeah, get index price. Maybe this is, well, I guess that's probably what they're referring to here. Yeah, when we're getting the token price here. I wonder if we actually removed the call to validate max utilization, would they still flag Reentancy? Because I think it's because of these prices here. Those are the external calls that I see. So if we go back, if we comment this out, I mean, obviously that's an issue for other reasons, but yeah, if we comment that out, now we're still going to be doing the index price here. So, I mean, that's still, but this is, let's see how smart it is. Because at this point, when we're just grabbing this price, we have not changed any state. So it's actually fine to make external calls. So like, for example, this safe transfer from, that is fine, and I actually would prefer to do the safe transfer from before we do anything else, because we want to get your tokens into this contract. You pay us before we do anything. Otherwise, if you for some reason you get access over the control of the transaction while we have updated our state, but before you have transferred us your tokens, that's an invalid state, and you can exploit that. That's really all Reentancy is exploiting some intermediate invalid state. So always safe transfer from. First, collect the money up front. That should be fine. This should also be fine, even if this was some kind of malicious external call that for some reason gave us the right price, but also re-entered. This should also be fine, because here we're just getting a storage pointer. here we are just loading in a position in the memory. That might not be fine, because here you could have cached a certain position, re-enter, and then, you know, during the reentrancy have that position change. But here, we still think this is an old position here. So you could charge borrowing fees twice. You could, yeah, this is going to, because I assume we're going to just write it. So yeah, that'll be an issue. But what we could do is we could turn this into a storage pointer. And then I think it would technically be fine. Yeah, I mean, or we could just move it down. So let's see how smart this is. We'll just put this right here. Now I'm claiming that there's no issues due to external calls, unless we're going to have to figure out what the collateral price is in this function. Nope. Yep. Okay. Okay, so here we got to figure out the collateral price, which means, I don't know, just for the sake of science, it's going to be, at this point, I don't even know how valuable this is, but just for the sake of science, let's just say that we remove the external call here. Let's just assign it to something bogus. We'll undo this. So this is for some science. Now, finally, let's go back to our function increase position. So, external call there, just grabbing a storage pointer. There's an external call here. We're getting the delta and storing the position. No external call here. No external call here. No. So, okay, now if we rerun it, let's see what happens. We got a new issue. Okay, so I mean, it probably picked up on something. Let's check out the, did we get a new issue? No, we didn't. Okay, so let's see the potential reentrancy here. It's still saying it. This one, yeah, probably because, well, these are the only two external calls here, but both of these are fine. Let's see, even if I take this and I move this here, let's see, I don't know, maybe it's even saying that like this and then this is some kind of an issue, which I think you could see that if you didn't have the context of like this being a separate oracle thing. So, yep. Okay, and then even if we just removed this one, we said like, just some bogus thing here. So we're one external call in the whole thing, and I think it just fixed it. It did. So that's pretty cool, actually. So it's not just doing like a very low analysis of external calls and just saying like, oh, this function has an external call in it and it's external. Yeah, there's a little bit of actual logic going on and saying probably making sure there's actually some kind of variables that have been updated before that. Though, of course, I mean, obviously it doesn't have all the context here that's that like getting the price here is, I mean, I guess technically, depending on the oracle, maybe you could manipulate it if there's some kind of callback here. But then, I mean, that's not any different than if you were to manipulate it right before the transaction. Maybe if you had to do it in the same transaction, I don't know. But, you know, decent sophistication with the detectors there. Let's just make sure we get everything back. I think all this logic should be fine. Gotta go to this function and put that, and then I think we're good. If I gotta go back to this and just uncomment this. That was our little experiment to see how smart this was. Okay, cool. Let's see. Oh, and there's little information here. I'm glad I highlighted over this. So let's see. It says modifying state after making an external call may allow for reentrancy attacks. Avoid making changes to state variables in a function after an external call. But it is smart enough to know that, like, even based on this recommendation, you'd think that they would flag just the transfer from, but they are smart enough to know that as long as we don't do something here, that's not an issue. So that's pretty cool. Let's go back. Let's see what's this medium issue that we've got. So, okay. Unused return from function call. I think that's pretty self-explanatory. Let's see if we can go to the line. Okay. Okay, so we're saying here we're not using the second return value from calculate realized P&L, which returns the size delta in tokens, which is just not useful here. Here we only care about the P&L. So, I mean, I think that's a good thing to check. That's a good like checklist item, and it's nice that it would be like automatically flagged for you, but nothing too fruitful with that one. So yeah, I think that does it for all of the detectors we had. So that is the static analysis tool. Obviously, probably a more complex contract would show off some of the more interesting detectors, but overall, one like pretty good, pretty decent, valid potential reentrancy flag, and then one where it's obviously is not really an issue, but it just requires some context to see that. So all in all, not bad. You know, definitely still worthwhile doing a run just to be sure. But now that we've looked at the static analysis from Olympix, let's have a look at another tool that they have, which I've mentioned I'm a little bit more excited about, which is the mutation testing. And part of the reasons I'm so bullish on it is they've made it actually just really easy. So let me show you what I've got for tests here. I'll just show off some of the test coverage and some of the ways that we're testing this system. So you can see we've got a decent amount of tests. You know, it's nothing crazy, but for a little 250 slok project, we've tested it, you know, relatively well. We've got a, you know, simple deposit flow, increased position flow, decrease with no P&L. We've got a decrease with profit for a long. We've got a decrease with a loss for a long. We've got decrease profit short, decrease loss short. We're doing a liquidation, or making sure we've got coverage for a liquidation test. We've got borrowing fees. So we're testing that the borrowing fees are right with like a pretty complex scenario going on. So yeah, I mean, not the greatest test coverage. There's a lot more interesting scenarios you could test for and stuff like this. And of course, you could get into fuzzing the system, et cetera, et cetera. But, you know, for 250 slok of logic, that's not bad. And we actually can run forge coverage and we can see how are we doing with regards to test coverage. And it looks like we've hit, so I'm going to focus on obviously the actual contract with all the logic in it. We've hit here 94% of lines, almost 91% of statements, branches not doing so hot, and functions, I'm sure there's some view functions or something that, you know, aren't going to be covered. But 94% of lines, that is considered pretty good in terms of test coverage, just from the perspective of how many lines did you cover. So the reason I think mutation testing is so powerful is it gives us another dimension to measure the quality of our tests here, because from this measurement of just line coverage, this looks like a really well-tested system. And you can only get to 100% on this metric. But in reality, there are other dimensions of logical coverage that I'm missing. And it's really impossible to measure that by just simply having line coverage. So what we can do with mutation testing is to test the coverage, well, to test how good our tests are at picking up issues. So you're testing the tests. You're seeing how good are the tests at uncovering issues. So what happens in mutation testing? We've talked about this a little bit before, but just from a high level, essentially, it's like you're going in and you're going into your contract and you're fundamentally mutating the code. So you're making, you know, some kind of invalid change here, which is like, hey, what if this set borrowing per share per second? What if this was flipped and it was that the if it was less than the max borrowing rate, then you would revert. Well, now I can't assign anything that's less than the max. So I've got to only be able to submit stuff that's greater than the max. So that's obviously wrong. That's obviously a bug. But if I come here and I run, if I just run a forge test, let's see. do we get any issues? Oh, we do in the setup. So maybe I'll choose a different one. So that was what we just did there is called a mutant. I just created a mutant version of our minimum perps contract. So let's make another mutant. So let's make a mutant that will probably catch with our tests. So let's say if we made a mistake here where we said the net P&L was the open interest of shorts plus the open interest of tokens shorts times the index price. So what this really should be is it should be you want to know the open interest of a short. So basically just what are the cost? What's the cost basis of all shorts? And then if the value of the shorts currently is greater, then that means that your short is not successful, right? The price went up. Then you have a net loss for traders. So this minus this is negative. If it went down, then this minus this is positive, and shorts have a profit. So let's say we mess that up and we put a little plus sign there because we thought, hey, there's a minus sign here for longs. So, shorts are the opposite. So let's just negate that, right? Sound logic. Let's see, does the math for our tests? And it does. The maths for our tests. And that is really surprising. I think what's happening is we didn't test the LP flow, because this is used for valuing LPs. It's not used for valuing individual trader positions. So our test here with, let's say, test decrease loss short. That's when you would expect to find it, but it doesn't. Because this is only testing the P&L realized by an individual trader. At least that's what would make sense to me. Yeah, we're measuring Bob USDC BAL after. So we got his losses there. But this is for the net P&L, which is useful for the people who are backing this market. So I would improve this test by writing, adding some extra assertions. Let's have the depositors withdraw, and let's see what kind of P&L the depositors end up with. That's what would catch this. But alas, in our test coverage here, our 94% line test coverage, we've not actually caught that. And that's a pretty big fundamental issue. So what we can do with mutation testing is just make as many of those as possible and test all of them, see how many we catch, see how many we miss, and then go and look at the ones that we miss, try to get that test coverage, and then also see if those are, problem areas of the code base, since we're not really having a lot of logical coverage for that area. So the whole process of generating mutants and then testing them is, pretty long, and you've got to compile every time you put in a new mutant, run the tests. So it's a bit of a time-consuming process, but Olympix has made it very easy. It's basically all done in the cloud, and then they'll just send you an email when it's done. So what we can do is we can do generate mutation tests and then specify the path to the contract. And I'll just hit enter here. And what they'll do is that basically that request has been sent. I think they must get all the bytecode, and they've got the bytecode for the tests. They've got the bytecode for the actual contract itself, and maybe they have the actual test code. I'm not sure what they do in terms of like privacy, stuff like that, but they're going to generate the mutants. So they're going to find all the different, like, oh, here we can change this to a plus, that's a mutant, we can change this to a divides, that's a mutant, all those little changes that you could possibly make. They're going to, for each one of those, run our tests, see if they passed or failed, and then they will give us basically a report of everything that happened there. So actually this was really quickly. I just got it. I mean, that was literally like under a minute. Yeah, I mean, it says, yeah, exactly. Under a minute is 50 seconds. So it did not take long at all. I mean, granted, I don't have a lot of tests, and also this project doesn't take long to compile. Definitely for larger projects, I could see this taking much, much longer. But you can see here, I'll just point out, they don't have a days measure, so it shouldn't be too bad. But okay, so let's see if I can, I guess we'll just download this CSV and we'll take a look. Okay, so we've got our spreadsheet here. Let me just increase the width of some of these lines so we can see what was the original code, and then we can see what was the mutated code. Let's just pull these open, and they're going to show us which ones passed, which ones are we lacking coverage for, and then which ones were caught and how they were caught. So it looks like all these down at the bottom, these were all caught. So let's just see, like for example, it looks like we made, let's see, 113 mutants. So they just, in under a minute, tested 113 different variations of the contract against our tests. So here they switched the comparison from total reserved is greater than the max to it's less than the max. So let's see here, line 333. So down here, yeah. So in this, basically turning that the validation can only be above the max. So basically just something totally invalid. And it was caught. It was caught by the test borrowing fees, test increase, and test liquidation function. So it makes sense. They're listing the multiple functions that would have caught it. And we can see here we've got really good coverage for some of these mutants, but then some of them we might have, only one test that covers it. And maybe it's even worth adding more to like double catch a mutant. So yeah, these are all the ones that were caught. Let's have a look at some of them that were not caught, and can they be an issue? So let's see this first one here. Changing literally what the max leverage is. I think that's, yeah, I mean, that's definitely worth adding a test for. Yeah, and I mean, this shows that we don't really have any tests that make sure that we can't go over the max leverage as it is here in this value, but maybe if you're testing based on this value, then of course you wouldn't catch it. All right, and here in the second one, I actually don't see a difference. Yeah, I don't see a difference in that one. So maybe that one's like kind of a failed mutant. Maybe I got it with like the underscores or something in the number. Here they've changed the number a little bit. I think they just added one way to it. So, yep, there's another one that probably would be good coverage on that. Let's see. Here they removed an only owner modifier, and this is one of the scarier ones. So it just goes to show that if something didn't have access control on it, our test suite would not be picking that up. So definitely this is one that it would be good to add negative tests to show that, hey, untrusted parties cannot call this function. This also goes to show that, hey, like if there was an issue for some reason with our only owner modifier, that might not be tested and we might not know about it. So here they changed like an is long to a not is long. Let's see, where was that? That was line 6, or not line 6, line 95. So let's jump there. So they must have the actual code of the contract if they're giving me line numbers. So yeah, I mean, again, probably we got a few of them, 95, 98. Yeah, they did this where they changed it from negative to plus. They changed it from times to divide. Stuff that, yeah, we're just not going to catch because we don't have coverage really at all of the P&L realization for the backing depositors. We should have some, but not nearly enough. So yeah, and I mean, the list goes on of other things, but definitely what you can tell from this testing already is like, hey, there needs to be greater coverage of this get net P&L function and that whole flow of backing depositors, how they are affected by trader P&L. That needs definitely a lot of more work to be done to thoroughly test it. But now you can get a sense of, how powerful this can be for another form of feedback other than just how many lines were covered by your tests, to give you something to measure yourself by before you're going into an audit. So I think this definitely goes a long way in catching some of the low-level, low-hanging vulnerabilities that really you don't need to hire outside expertise to catch. Instead, you can just run something as simple as Olympix generate mutation tests and get that feedback for yourself without spending, however many tens of thousands of dollars on a review. Get those low hanging issues out of the way. Let's get like all of the logic bugs sorted, because you've got great test coverage after you're passing all those mutants. And then now when you get an audit, you're going to get an audit that's worth, 10 to 20 times more than you paid, because the researchers are going to be having to work really, really hard to actually go and find some juicy bugs and uncover something interesting in your code base. And furthermore, instead of getting one audit or two audits, because the first one just, wasted a ton of time on these low hanging fruit, you can do one audit and have like maybe one notable issue in it if you really, really test this, really thoroughly, and the system's not too complex. And then you'll be able to get to mainnet, or, two audits instead of three audits, or X minus one audits versus X audits. And that can really, really make a huge difference in terms of timeline and, of course, also budget. So just speaking from the perspective of getting ready to launch, I think this is probably way more valuable than even just measuring test coverage by line numbers. So I'm definitely very bullish on mutation testing. And then also for auditors, for security researchers, using a tool like this to go and see like, okay, well, that's pretty sick. I can see basically a heat map of all the different lines. We've got, a lot of them are grouped up on this right here. What's up? 113 through 117. That's pretty interesting. So like, yeah, all this net P&L stuff, that has like basically no logical coverage. It might have line coverage, but like basically no logical coverage. So like pretty much guarantee you look in there, you're going to find some kind of issues because that hasn't been thoroughly tested. So yeah, it's like a map to like, here's where the bugs are. X marks the treasure. So really love mutation testing, and I love the way that Olympix has implemented it here, making it pretty much hands-free. You don't even really have to know the inner workings of mutation testing. You just, run the command and it shows you, here's a list of things you need to look into. So that's all I have today. Definitely go ahead and head over to Olympix. Definitely try out the mutation testing. I think they've got a live beta going on. And of course, they've got tons of other tools that they're continuously working on, and some other cool stuff that I'll have to check out personally. And, maybe there'll be a follow-up video on some other cool stuff going on here. But overall, really excited about the mutation testing, and probably something to be trying to use more often now. So with that being said, I will see you guys in the next one.